Hey, good evening. So welcome back to Calc 2. This is going to be your quiz 3 review. And let me just go ahead and give you an idea of what's going to be on it. Okay, mostly I'm breaking up chapter 9 into two parts here. I have our 9.2, 9.3. It's C 9.1, but there's not a lot of good questions to ask in 9.1. And I really don't want to quiz you on things like what shape is z equals x squared plus y squared and try to have you guys memorize all of that. That's, I mean, we kind of had to, but I honestly have never been in a position where it's like, quick, name this particular shape. So I'm not asking you about that. However, we are going to be doing partial derivatives. Okay, so actually, let me pause. If I don't share the screen, you're not going to see what I'm writing. I think I've learned that by now. Okay, so 9.1, not so good. 9.1 has questions like, what shape is this? I'm not asking you that. Okay, so 9.2, 9.3. Okay, pause this for a second to bring up part of your quiz here. Okay. Just brought this one up. So this is literally part of your quiz, okay? The answer is true, by the way. So when you have to find extrema, one of the things you have to do is you have to consult this chart where you have to take the second derivative of x, the second derivative with respect to y, and then the second derivative mixed matched. Okay, so x then y or y then x, it won't matter in this case. And then depending on what this value is, the a and the b is because there's got to be a certain value that you're going to have to plug in. Sometimes if it's a constant, okay, the a and b is irrelevant because it's that number for every a and b. Okay, so for example, if I get fxx, fyy minus this thing here, and they all happen to be quadratics, okay, by the time you take the second derivative, they're just constants, right? You take the derivative of x squared, we get 2x. Take the second derivative, we just get x. So it is 2 for every value of x and y. Okay, it doesn't matter. So if it happens to be something where you still have an x or a y left, you can plug these numbers in and then consult what's going on here. Okay, I don't think your book actually has one. No, it has like one. Yeah, there's a few that are that complicated, but not too many. Okay. So what you're going to do is consult this thing, and if the d happens to be greater than 0, right, then we consult our fxx and decide what's going on. If it's equal to 0, then we have no information on this, and then if there's a saddle point, we're going to get that it's less than 0 here. Okay, so you absolutely have access to what this thing is supposed to be. So it's just true. So don't stress, don't trouble yourself by trying to memorize this formula, taking the derivatives and realizing what you have to do. That's enough. Okay, so this is literally question 5 for you. You have this access to there. It's in the quiz, so I know you guys can see it. All right, so you'll have it. All right, so actually, because we're going to be doing something that's going to need this, I might want to write this down too, because when you have to know this, you'll know better. So when, you'll take a class that has a lot of things going on with this, you can memorize them, okay? But if you don't do them for a while, you tend to not have them memorized. Okay. So let's just get into it and start doing some problems and see where we're going to go. Okay. So what do we have here? We have, okay, there we go. Oh, get rid of that too. There we go. Okay, so we have z is equal to, okay, z is equal to 6x squared minus 4xy plus 9 squared. And we're going to find our derivatives. Okay, so just pay attention and try to read what it's asking us, because there's a lot of questions that can come out of any single problem. And I really don't want you to do more than what it's asking. What it's asking is plenty. Okay. So in this case, we have to find the first partial with x and then the first partial with y. And then once we have those first partials, they're going to ask us to evaluate it at certain points. Okay, that's all we have to do here. Okay, so if I want derivative of f with respect to x, partial of x with respect, partial of f with respect to x, we're going to end up with a 12x minus, now x is the variable, for y is a constant, okay? Since y here is a constant and it doesn't have any x terms in it, that's where we are. df dy, again, x is a constant as far as y is concerned. We get a negative 4x because we're taking the derivative with respect to y. So it's kind of like saying, well, what if we had like negative 4 pi y and I wanted to take the derivative with respect to y here? Would this be negative 4 pi? So that's how the x is being, that's how we're dealing with the x. We're treating it as a constant, y is the variable. Plus we have 18y, okay? And if you'll excuse me, I'm gonna go take care of okay. Oh, it's gonna be a long night. Okay, hold on. All right, here we go. So there's our first partial derivatives. All we're going to do now is we're just going to plug in the points that they wanted us to plug in. They said on this one, 2, negative 5. Okay, they wanted 2, negative 5. And on this next one, they wanted negative 5, negative 3. Negative 5, negative 3. Okay, f of those things. So all we're going to do is plug those in. Here. Okay, so this is going to be 12 times 2 minus 4 times negative 5. This one here, this is going to be negative 4 times negative 5 plus 18 times negative 3. Okay, and we're just going to do the arithmetic. This is 24 plus 20, so we get 44. Here we have 20, positive 20. Okay. 18 times negative 3, 18 times 3 is what, 30, 48. So this is minus 48, so this is going to be negative 28 and 44. So that would be a very reasonable question for me to ask you. Okay, take the first partial derivatives and evaluate them. I try not to ask too much on any one particular question because, quite honestly, there's a lot of repetition with this, but there we go. Okay, let's see here. We have one with exponents. Oh, we do. Look at that. It's one with exponents in it. All right, let's go ahead. I'm going to dress this one up a little bit more. Okay, so we're going to take that one as inspiration, but we're going to go ahead and change it a little bit. Okay, so we're going to do negative 6x e to the 6x minus 5y. All right. So the first thing you have to figure out is like, what the heck does this y mean? Okay, so what this plus or minus up here means, right? It was negative 6x to the negative 6, so I changed it. Okay, and then we're going to have times e to the negative 5, right? When the bases are the same, oops, there's an e here. I wouldn't do the other one to you. It's not that you can't do it, it's just that it requires a certain rule, and I didn't tell you have to memorize that one, so. Nor did you have any homework that even looks remotely like it. Okay, so we have 6x times e to the negative 5y. When the bases are the same, we add the exponents. That's how come it works like this, okay? So what we have here is, let's take the derivative with respect to, let's go with x. So we'll say fx, okay, or sorry, we're going to write the derivative part here. This e to the negative 5y, there's a times here. So there's negative 6 and this e to the negative 5y. But that can all float out. So we actually can put this over on the side of the derivative that's been handled. Okay, it's with constant times, what do we have left? We have x e to the 6x. Okay. Now, do you remember what happens? Because we have a product here, don't we? So we have a product rule going on here. Okay, so this is going to be negative 6 e to the negative 5 y. Okay, because as far as x is concerned, these are constants. So because they're all times, they just float out right on out. But now we have the derivative of this thing. It's a product rule. So it's derivative of the first times the second, okay, plus the first x times the derivative of the second. Okay, did you catch that? So it's derivative of the first, derivative of x is just x times the second plus the first x times the derivative of this piece here. So we have e to the 6x times the chain, and that's how we're going to get this. Okay, so if I put this back in, okay, we have an e to the 6x in both cases, so we could factor that out. Okay, so we have negative 6e to the negative 5y, e to the 6x, and then what do we have left? We have a 1 plus 6x. Okay, so we could say this is negative 6e to the 6x minus 5y, 1 plus 6x. Right, that would be my derivative with respect to x. Okay, now if we want to do derivative with respect to y, okay, so we're going to write down the problem. We're going to say negative 6x e to the 6x times e to the negative 5y. Okay, so remember, we add, the bases are the same, we can add the exponents. So we're allowed to pull them apart this way. Okay. So what's going to happen next is, well, all of these pieces, right, this is all times, but all of these pieces, right, are constant as far as y is concerned. So if we wanted to take the derivative with respect to y of this stuff here, okay, then all of the x stuff can float through the partial with respect to y. Okay, can't float through the partial with respect to x, can't do that, but it can all come back through the partial, oops, there's an x, the partial with respect to y. All right, so taking this derivative, we end up with negative 6x, e to the 6x, that's all constant, times e to the negative 5y, times the chain, so there's a minus 5 here, okay, because the derivative of negative 5y is just negative 5. Now we have to put all this together, so this is going to be 30, 5 times 6, x e to the 6x minus 5y. And that would be our partial with respect to x and y. Let's do partial with respect to y. If they ask you to plug in a value, we would simply plug in those values. Okay, I don't think you need me to show you that, but we'll be okay with that. Right? Right? Okay, let's do this one. This one looks harder. Okay, so here we go with this. We have x squared plus 4y cubed over x cubed plus y to the 4th. Okay. Now, what I'm going to do is I'm going to pull this apart. Okay. That's y to the 4th. All right. And actually, I'm going to do one more bit of surgery on this thing because I would, we could do this. Okay, we won't do more surgery on it. Just go from here. Okay. So I wanted to know what is the partial of x. Okay. So because we have an x in the upstairs, we have an x in the downstairs. We have to use the quotient rule. So that's the derivative of the top, okay, times the bottom, okay, minus the top times the derivative of the bottom, okay? This is just chain rule, and I haven't taken a derivative yet. I just set it up, okay? And then we have plus, and in this case, right, with this one, we're going to say this is 4y cubed, and then we have an x cubed plus y to the 4th to the negative 1. Okay, that's what this piece is. So the only piece that has an x in it, right, is this thing. So this is going to be a chain rule. So this is going to be 4y cubed times negative 1. That's this negative 1 here. It's coming down in front. We have x cubed plus y to the 4th to the negative 2. That is the derivative of the reciprocal function, 1 over x. Okay, and then we need the chain. So this part is y, this part only has y in it, so this chain is 0, but it's times 3x squared, okay, from the chain rule. All right, So here we go. We're going to have the derivative of the first, 2x times x cubed plus y to the fourth minus x squared. And then we have to take this derivative. So this is going to be 3x squared plus y to the fourth times 6x. Right? Oh, shoot. Just made the same mistake a lot of you guys make. No, that's all right. We're good. We're just trying. What am I doing? Get confused. Okay. We just want to take the derivative of this piece here. Okay. It's just going to be 3x squared. If I take this derivative, it doesn't work. Okay. It's just 0. Okay. So, and don't forget, we're going to have a y squared at the bottom. Right? Whatever the bottom squared was comes into. Okay. So this is x cubed plus y to the fourth squared. Right? That's our chain rule. Right? Derivative of the first times the second minus the first times derivative of the second, all over the bottom squared. And then plus, and then we have this that here. So we have 3x squared times 4y cubed. So that's going to be 12, right? 3 times 4, x squared, right? Times y cubed all over x3 plus y to the fourth. What's the power on this? 2. It's negative 2, so that goes down on the bottom. Okay. So in hindsight, when I'm looking at this problem, probably shouldn't have bothered separating them out. But sometimes that's a better way to go. Just something that I usually think about. But in this case, not so much. Okay. So here we are with this. We have, let's go ahead and crack this thing open. So we have 2x to the fourth plus 2xy to the fourth minus x to the fourth, right? Or minus 3x to the fourth, rather, plus 12x squared y cubed, and then it's all over x to the 3 plus y to the fourth over 2. And after that, I think we could say 2x to the fourth minus 3x to the fourth. So we're going to have 2x to the y fourth minus 2 minus 3 is 1. So we have 1x to the fourth here plus 12x squared y cubed, all divided by x to the 3 plus 4y to the fourth squared. And that would be our solution for this thing. Okay. One moment. All right. Same idea for the y derivative. Okay, except I'm not going to spread them apart this time because it didn't seem like it was really helping. So let's not worry about that. Okay. So we have fy is equal to, okay, well, actually, we just have f. I'm not going to do of y just yet. I'm going to take the derivative. I haven't taken it yet. Okay. So x squared plus 4y cubed, x squared plus 4y cubed all over. And this was, so go down further, x to the 3, y to the fourth. Okay. X to the 3, y to the fourth. Okay. Still quotient rule. Sorry. Okay. So derivative of f with respect to y is equal to. Okay. We need to take the derivative of the top, squared plus 4y cubed. Okay. Times the derivative of the bottom, times the bottom. Okay. Minus the top times the derivative of the bottom, all divided by the bottom squared. By the way, don't multiply this out ever. Okay. So unless they ask you to, then you can. But I would prefer you did not multiply this out. You're not on the hook for it. I'm not going to be grading on that. If you do, it's fine. It's not wrong, but I will pity you. Okay. So go ahead and take this derivative. We have 2x. Now, oh, no, we don't. This is with respect to what? This is respect to y. Okay, so this x squared, that's a 0 if we take that derivative. Plus, we have a 12y to the 2, okay, times x cubed plus x to the 4th, okay? Derivative of the top times the bottom minus the top, x squared plus 4x to the 3. And now we need the derivative with respect to y of this term. The derivative of x cubed, that's 0. The derivative of y to the 4th is 4y cubed. Okay. And then the bottom here, okay, notice there would technically be a 0 here like this, okay, because this derivative. So we have, let's do this. Okay, x to the 3 plus y to the 4th squared. Don't multiply this out, leave it alone. Okay, 0 plus anything is that anything, so we have 12. Let's go with x's first. Okay, so we have 12 x to the 3 y squared. When the bases are the same, we add the exponents, so that's going to be plus 12 y to the 6th. Okay, minus, here we have is y to the 3. So we have minus 4 x squared, okay, y to the 3. Okay, and then here we have minus, don't forget, this minus has to go into those places. So it's 4 times 4 is 16. And then we have y to the 6th. All right, and then we have x cubed plus y to the 4th squared. You should go through this operation to make sure, because there's some stuff that usually cancels. Okay, so this is going to be 12x to the 3 y squared. These are different. Minus 4x squared y to the 3. Okay, 12 minus 16, right? These are both y to the 6s, so 12 minus 16 is minus 4 y to the 6th, all divided by x3 plus y to the 4th squared. There's nothing we could do with multiplying this out, canceling something. We're done. Okay, so there we go. There's our answer. Again, if they give us numbers to plug in, I don't think I gave you numbers for something that was this complicated. I'll just go ahead and leave it, and then we're set. Okay. All right. What if I go to the next section? Okay, so I'll be right back. We're going to go ahead and do that. All right. So welcome back. I'll try to find a good one. So this one looks reasonable. Okay. So here is fxy is equal to x squared minus 4xy plus y squared minus or plus 18y plus 9. Okay, let's have a look at what that's going to be. Okay, so that is going to be x squared minus 4xy, okay, plus y squared. Okay, plus 18y minus 9. Here's my f of xy. Okay, so what we have to do, right? We're finding a local min or a local max. Okay, so the way we did that in one variable, so take the first derivative, set it equal to x, solve for x, and hope for the best. So here is my df by dx. Okay, so that is going to be 2x minus 4y, 0, 0, 0. Okay. While we're at it, I'm going to go ahead and take the second derivative. Okay, so if you're wondering and said, wait, we didn't take the second derivative on the first one, that's because I knew you'd be taking a lot of second derivatives on this part. So I wanted to keep them as, I wanted to keep the problems reasonable. Okay, so df by dy, what do we have here? We have negative 4x because we're taking this derivative with respect to y, plus 2y, okay, plus 18, and of course 9 actually is a constant, so that's done. Okay, And if we go ahead and take our second derivative with respect to y, okay, we're going to have 2z. Okay. And if I take my first derivative with respect to x, that would be this one, and then take it with respect to y, that would just be -4. Okay, similarly, you don't have to do this. df, and then we have dy, and then we take our derivative with respect to x. So we have df, take the derivative with respect to x now, we get -4. If you want to use that as a check, you certainly can. Okay, but what we're going to do is we have a system of equations. We have 2x minus 4y is equal to 0. It's for this right here. We also have -4x, okay, plus 2y, okay. Now I'm going to say plus 18 equals 0, okay. So we're going to say that this is 2x minus 4y equals 0. -4x plus 2y equals -18. We have to solve this as a system of equations. You have as many ways as you want. You can solve this as long as it's legitimate. It's fine to solve it any way you please. Okay. Elimination is usually easier, but if you want to use substitution, that's fine. You want to do something fancy like Cramer's rule, that's fine. Okay. However you want to do. You want to factor out 2's first, that's fine. Okay. So we're going to multiply this one by 2. Okay, so we're going to have 2x minus 4y equals 0. We're going to have 2 times 4, that's -8x. Okay, plus 4y is equal to 2 times 18 is -36. Okay, and we're just going to add. So we're going to add these two, we get -6x. Add those two, we get 0. That was the point. Okay, you're trying to eliminate one of the variables. Equals -36. We divide both sides by -6. We get x is equal to 6. Okay, once we have a solution, pick your favorite one. Okay, pick any equation you want that we've done so far. Plug the x back into 6 for it. Okay, so we have 2 times 6 minus 4 times y is equal to 0. See that? Okay, so we have 12 minus 4y equals 0. 4y equals -12. Divide both sides by -4. We have y is equal to 3. Okay, so the point we have here, our a and b, is 6, 3. Okay, now when I come back up here and look at it, I'm like, wait, the second derivatives were all constant. That's fine. That just means that they're always that value. So that's great to have points. You didn't need them because they're always going to be these values. Okay, so we're only investigating one point. Okay, this is the only point that could be a min or a max. I'm not really sure which it is right now. Okay, so we're going to calculate the determinant. Okay, that's the d. It's a determinant here. And take linear algebra, we'll do that there. Okay, so it's f squared x, f squared y, so it's 2 times 2. Okay, so this is 2 times 2, okay, minus, because right, that's our deal there. And then we have fxy and y of x, so it's times 4 squared, -4 squared rather. Okay, so here we have 4 minus 4 squared is 16. 4 minus 16 is -12. Okay. Did I really not write this down after I did it? All right. I believe when d is less than 0, we have a, I believe we have a saddle point. At the point, right? At the point, which point did we come up with? 6, 3. Okay. And that means there's both a min and a max. It's a min in one direction and a max in another direction. So saddle point is named because you've got something like this going on. and something like this going on. Okay, so it's a max here, or min here rather, and a max in this direction. Okay, so I didn't draw it very well because you have to think about like it's doing this like north to south, and then over here from east to west it's doing something like that. Okay, so that's what we're dealing with. I don't think I put any where it would have given you a 0 because I didn't want you to not have an answer, because we do have a problem like this in the homework. But it was a fairly, I won't say obvious, but graphing it a little bit yielded nice result as far as like deciding what it was going to be. But I did not give you one like that because it's a quiz, and I was like, how much do I want to stress them? Yeah, this one. I did not do the this kind of a question. Okay. There will be a word problem. Okay, I picked one of the ones out of your homework. So spas and heaters. Okay, labor costs and with a camera. Okay, so it's got to be one of those two. Okay, or one of the other ones that are in there. But I think this is it. Okay, so these are the two that I picked so that you guys would have a reasonable chance of doing something. Didn't want to come up with like, here's a brand new problem for you. I don't guide you though. I kind of let everything up to you. Okay, so I don't give you a prompt. It's up to you to know. You have to take a first derivative, set it equal to 0, take a second derivative, and consult the chart. Okay. I'm going to stop here because I think it's probably long enough. But your quiz 3, simply just on 9.2, 9.3, you are afforded the equation to know whether or not it's a max or a min. That table that I showed you at the beginning, that is in your quiz. All right. Good luck. If we need something else to happen, please let me know. And yeah, I'll see if we can't sort that out for us. Okay. So thank you and good luck.